Hey everybody, thanks for checking out the channel. Be sure to like, subscribe, and turn on notifications to keep up with all the latest RC crawler explorations. For this episode of The Truth Is Out There, this video was sent from Erwin from Team Revolt based in Belgium, and he's got a mystery he wants me to solve. He's wondering why the passenger side wheel is lifting up. He even posed the question in his original video. On this channel, we explore the mysteries behind our grown-up toys. This is a textbook case of torque twist, and that occurs on all shaft-driven vehicles. On this particular obstacle, there are a couple things exaggerating this effect. Torque twist is common and unavoidable on all shaft-driven vehicles. It comes from the motor wanting to rotate around the first spur gear that it meshes with in the transmission. There's also another category of torque twist that comes more from the mass and inertia of a high-power engine that's accelerating super fast. That's more of a dynamic torque twist, and what we see on crawlers is more of a static torque twist. Since the motor is attached to your skid and the chassis, the entire chassis will twist relative to the axles. What you see here is the chassis rotating around the rear axle and the front axle rotating in the same direction around the chassis. In the video, you can see first that the chassis is rotating relative to the rear axle. Then look at the front shock on the viewer's left. It compresses second. So you've got twist coming from both axles, and it makes it look like the front passenger wheel is lifting. On your rig, it could be the left or the right, depending on which direction your motor is facing and how many gears are in your transmission, but it's always going to be the same side for a given vehicle that wants to lift. Two things that are amplifying the twist in this example. First is the off-camber terrain. The rig is already tilted in the direction that the chassis is twisting. That doesn't help. Second, it's turning in a less favorable direction. There are not a lot of great solutions to this, but let's talk through a couple. And if you stick around, I'll show you how you can actually use torque twist to your advantage. One method that isn't great is to stiffen the springs. This reduces compression of the shocks and resists body roll on the downhill side. Ideally, you would just stiffen the rear driver's side spring to balance this out, because again, the truck is always going to lift on the front passenger side. The downside to this is your rig will react asymmetrically in different situations. It's best to maintain balanced performance over a wide range of terrain and not try to tune specifically for this one situation, or to try and counteract the twist with springs. One might argue that adding preload to the driver rear spring would help, but there's a fundamental difference between spring rate and preload, and I have a video explaining that. Adding preload does not stiffen the spring, it simply raises the ride height, and you don't want one corner riding higher than the others because then you'll be driving down the road crooked. Another method that isn't great is thicker, slower oil, which is a super common recommendation, unfortunately. Thicker oil simply delays the inevitable. It will slow down the twist, but the longer you sit in that situation, eventually the chassis will tilt and roll to its balance point. Even worse, if you have very thick and slow oil, you may prevent movement altogether, and that will prevent articulation in other situations when you want it to move. I have a video with some tricks on how to test and select your shock oil weight. Another method that works but also isn't great is you can add weight to the front passenger side. This will make that front corner heavier and harder to lift up, but it also skews your weight balance in other situations. It's best to have 50-50 left and right weight balance so the car is equally stable in a variety of situations. If you didn't think this channel was controversial, here is where, let's say, differing opinions will start to emerge. One of the biggest myths surrounding torque twist is roll center. The roll center of the chassis can be determined and tuned with the geometry of your suspension linkage. Sounds great, right? Unfortunately, the point that many people overlook is that roll center is a dynamic response to fast cornering. You have to be driving fast and turning quickly to induce a sideways acceleration in order for the roll center to be relevant. It has no effect at slow speeds. The other big myth is that portal axles reduce twist. Notice that this is a portal axle rig and is twisting. The thinking is that some of the drivetrain gear reduction is moved off the drive shafts and onto the axles, where they don't contribute to twist. I can see how that might make sense, but it's fundamentally flawed. Twist actually comes from the total torque between the tires and the pinion. It doesn't matter where that reduction occurs. Only the total reduction matters. I even confirmed this with 74 Weld, who builds full-scale portal axles. And I have not one, but actually 2 videos explaining this. Lower gearing. This might seem counterintuitive, but the lower your total gear ratio is between the wheels and the motor, the less twist you will get. Back to portals. A typical portal axle reduces your overall gear ratio, and that, if anything, is what prompts people to think portal axles are reducing twist. It has nothing to do with the fact that the gears have moved. It has everything to do with the fact that you've reduced the total gear ratio. So you can achieve the same effect as portals by reducing your pinion size. Think on that for a minute. Next, drive with less torque. Reduce the throttle and you will reduce the twist. Creep as slowly as possible. Next, you can brake rear traction. Most of the twist comes from the rear axle because when you're climbing, there's more weight on the rear axle. So if you can get the rear wheels to slip, that twist will dissipate. If your front wheel is stuck up, which is common with very heavy oil, you can correct it by turning the front wheels away from the lifting wheels. And there's a great example of this in the video. See that correction? If the front passenger side is up, turn driver. If you have dig, this is a great time to use it. Disengage and lock the rear wheels and the twist will dissipate. The only real mechanical solutions are motor on axle, or MOA, and hear me out, belt drive, which doesn't really exist in crawlers because it's simply not practical, but you will see it on touring cars. Finally, learn to embrace your twist. Step 1 is to know which way your car twists, and if the passenger side lifts, that means the driver's side is pushing down and pushing down into the terrain. So use that downforce to your advantage. If the terrain allows, you can use the driver's side wheel to better hook onto edges. If the obstacle gives you the option, use the wheel that is not lifting to reach up and over an obstacle. You can also use twist to keep your front wheel from dropping down into a crack. See how it stays up when the throttle is on, but falls down as soon as the throttle is released? If you're clever, you can use that twist to keep your front right wheel up. If you come across a video or a driving situation that you can't explain, especially if you think it defies known physics, send it to me and I'll attempt to break it down.